The Evolution of God, the Theory of Evolution, and the Potential Existence and Nature of God in 15 minutes or less. James Carroll has a PhD in computer science and a minor in ancient Near Eastern history. As a graduate student, he taught Pearl of Great Price, Isaiah, and the Book of Mormon in the BYU Ancient Scripture Department. He's currently working at the Los Alamos National Laboratory doing ensemble machine learning research and computer-assisted radiographic analysis for nuclear stockpile stewardship. His interests include machine learning, statistics, linguistics, consciousness, comparative ritual, and photography.
Make sure I know how this works. All right. The theory of evolution is perhaps the most important scientific theory of all time. It explains more of the universe around us in a more simple and beautiful manner than does perhaps any other theory in human history. Perhaps the most powerful aspect of the theory of evolution is its ability to explain the glorious complexity we see around us. Through a natural process, according to evolution, complexity arises naturally and gradually from simpler predecessors. We see here the first life form at the base, and then as time goes on, things differentiate. Some become more complex, some stay simple. But the complexity is explained through that path back to the simpler predecessor. And I have no idea how to say this man's name. He famously said that nothing in biology makes sense, except in the light of evolution. But I believe that this does not go nearly far enough. Computer scientists, which I am, tend to see biological evolution as just one form of a larger class of search strategies, known collectively as genetic algorithms, which are all around us, and which impact far more of what we see around us than just biology. Therefore, I believe something a little bit more radical. I believe that nothing in biology, technology, linguistics, history, culture, politics, theology makes sense except in the light of evolution. So let me try to explain what I mean by all that. Obviously, things evolve in biology, right? But technology does too. In fact, technology doesn't so much be invented as it does evolve into the local possible. Right, the adjacent possible, from more complex, from simpler antecedents to more complex forms as we move forward, and they combine. And this is what Matt Ridley called ideas having sex, just like we see in evolution. And you'll see that, for example, look at the zip drive, the USB drive. There is a combination of flash, chip technology, USB technology, and storage media. All those technologies converged, mated, and produced this new form of technology. So technology slowly advances, it mutates, and it has sex. And so not only did technology evolve, our languages evolved, right? Our ideas evolve. This is the idea of storytelling. You've got a family tree, right? So nothing in any of these fields really makes sense except unless you view it through this idea of evolution, to really get a feel of what's happening and where it's coming from and where it's going. I want to explore how that connects to theology. Now, much has been said about the potential existence and nature of God in the philosophy and theological literature. But to date, not much has been written about the potential implications of the theory of evolution to the potential existence of God and to his nature. I believe that the idea is worth having in as much as it is true or not true. And so whether the God idea should survive depends on whether there's anything to it. And we should base it objectively on that question and on that question alone. So, first thing that I think we could maybe say about this has to do with what I call the God of nature or the God in nature. Let me explain what I mean. A lot of people see God as a being who exists outside of our world and our nature, who creates our natural laws, right? He's the prime mover. This is a very Greek philosophy of God. The prime mover exists outside of nature, creates our nature, and everything we see around us is a result of him. The other view of God, though, is Arthur C. Clarke's view, right? That anything that's sufficiently technologically advanced looks like magic. This is a being who exists within nature, within the laws of nature, and who uses the laws of nature to do things that we would consider magic. It's a God in nature. So the question is, which is right? Well, understandably, many people do not believe the beautiful and complex world they see around us could have happened simply by chance. It's an understandable reaction. So to solve this problem, they propose the existence of a more beautiful and a more complex being that they choose to call God, who they say created our beautiful and complex world. Unfortunately, if you think about that for just a minute, you realize that does not solve the problem in any way. It creates a far bigger problem. If the world we see around us could not have happened by chance because it is too beautiful and too complex, then certainly this more powerful, beautiful, and complex being could not have happened by chance either. In fact, such a being would either be more unbelievable than the universe he was imagined to explain. Remember, what we learned from evolution is that it taught us that complex and beautiful and amazing things happened because of gradual modification from simpler predecessors and antecedents. So Richard Dawkins explained it this way. He said, aliens would be to us like gods. Of course, he refuses to then call them gods. But luckily for us, Richard Dawkins doesn't get to dictate what we believe and worship. Anyway, aliens would be like gods, but they would not really be gods because they'd have to come from somewhere. The laws of probability forget all notions of their spontaneously appearing without simpler antecedents. They probably owe their existence to a perhaps similar or unfamiliar, version of Darwinian evolution. So now we need to clarify what we're about to do here. Despite the vehement assertion of some, the reasoning I have just presented does not prove or disprove the existence of a supernatural God. Right? So we need to be very clear. It's entirely possible that a supernatural being who created our universe and all that other stuff, more beautiful than the universe, exists. I cannot prove he does not through this line of thinking. It's impossible to do. What we can say is that using the statistical reasoning, kind of a Bayesian approach, if you know me, I'm a religious utilitarian, I've been made fun of that already, and a religious Bayesian, and so all we can say is that one of these theories using Occam's razor is more probable than the other, so far, because of this evidence just presented. And that's really all we can say, and if we say more than that, we're not really being scientists anymore. So one of these theories is more probable than the other, and that's all we're going to say. And that's all we should say. All right. So that's one thing that evolution can tell us. Not what God is like, but what is more likely to be right. But maybe it can tell us something else. And maybe one way to do that is we can assume that anything worthy of being called a God is probably more complex than us. And so what we could do is we could look back through the theory of evolution and the history of evolution, and we can say, now, evolution does not always produce complexity. That's one of those things that is a myth that really does need to be squashed. Sometimes evolution takes complex things and makes them simpler because they survive better that way. Evolution does not favor complexity. It favors survivability. However, evolution is designed as a theory to do, among other things, explain the complexity we see around us as one of the things that evolution can produce, among many others. So what we could do is let's throw away the myth that evolution creates complexity every time, and let's just say, when it creates complexity, how does it do it? Because if we can figure that out, and if it does it the same way every time, we may have a window to look forward. So I'm going to go through the history of evolution and try to look at what happens when evolution creates complexity. And every time that I've ever seen, there's some form of cooperation, specialization, trade, tool use, and collectivism going on. And that's how evolution creates complexity, when it creates complexity, which it doesn't always do. So let's do a history of evolution of complexity for just a minute. Probably the first organism that we could really say evolved was probably an RNA molecule. We actually don't know this. We think it was RNA because it could both could both catalyze and store information and therefore evolve. So we probably start with an RNA molecule, but we don't end there. The RNA molecule makes a friend called DNA. We don't have no clue how this happened. But somehow they specialized, and they said, DNA, you store the information, I'll metabolize the operations, and we'll do it better than either of us could alone. Right? It wasn't a zero-sum game. They cooperated, and they traded, and they specialized. Right? And they did it better because of their cooperation, specialization, and trade. And then they got together with some other things called proteins, and they started building cell coats and other things. Richard Dawkins called these survival machines, right? So we start building survival machines to help the DNA procreate. And these things really are machines. We have a tendency to think of life as something special, something different than the computers we build, right? But if you zoom in on these things, they're machines. And there's nothing terribly special about these machines if they can be conscious. For example, if they can be conscious, or if we can be conscious, and these can be conscious, so can a computer, because it's just, both of them are just machines, right? So we have a machine here that moves things around, or builds cell coats, or metabolizes ATP. And what's interesting about that is when I say, what is alive? When we say, is a cell alive? You say, yes, but you don't say the DNA is alive. You say, the cell is alive, right? Well, that means we consider the whole cell a living thing, right? So let's look at the cell coat for a minute. Is the cell coat a survival machine to help the DNA procreate? Or is the DNA an information storage device to help the cell wall procreate? Well, the fact that you can't answer that question means that they've merged together to such a degree that they've become one new, unique living organism. We could call this maybe transmolecularism, right? And in transmolecularism, these cells have merged together, and the cell wall and the DNA, they merge together till they're one new living thing, a cell. And then it got better because a couple cells got together and they created the eukaryotic cell, which is one cell living inside of another, where one cell specializes in energy and the other cell specializes in other stuff. And they put a bunch of these cells together somehow. Again, we don't know exactly how this happened. And through symbiotic mechanism, these cells merged until the point where we consider this one living organism, but it's not. It's several individuals who have combined into one collective, specialized and traded, and created one new thing. And we call that new thing transcellularism, right? All right? And then a bunch of these collections of cells merge together into collections of cells. And then they start to specialize and form structure, right? And we get each of the cells that they specialize to the point where they start looking different, right? You've got nerve cells and motor cells and blood cells, but they're all the same organism. And then those form systems, cardiac systems, cardiac cells, cardiac systems, right, and muscle organs. And you put all these organs together and you get a human being or any other being, animal on the planet. And it's beautiful, right? You look at it, it has function, form, beauty, and consciousness, right? But what is it? It's a collection of individual cells who are themselves collections of individual cells inside of each other, who are themselves collections of individual molecules who are all working together in a hierarchical manner and specializing and trading, right? And of course, it's not done. We're not done because we people are starting to get together, and together we build things that no one of us could ever build before. So, for example, who here knows how to bake a pencil? Is there a person on the planet who knows how to make a pencil? And the answer to that question actually is no. Right? Because the guy who makes the rubber for the eraser doesn't know how to make a pencil. He knows how to make the rubber. The guy who drilled the oil well, that got the oil that we use to make the rubber, doesn't know how to make a pencil. He knows how to drill oil wells. The guy who brewed the coffee, right, or the guy who farmed the coffee that the oil man drank before he, right? And you start realizing what all this stuff that goes on, and no one person can build a pencil. There's not a person on the planet who knows how to make one of those, right? It can't be done. And then compare that to this computer sitting here next to me, right? In other words, we create things that no individual member of our society can create by specializing, trading, and forming a collective intelligence where each of us has one piece of the puzzle and we put it together and we build something even better than any one of us could build alone. It's a collective intelligence. And that sparks our technological evolution that has come in the last little while. All right. So where are we headed? Because if we can tell maybe where we're headed, given Lincoln's view of God as a post-human, right? If we can tell where we are headed, we may know something, we may be able to say something more about God. And the way to tell where we're headed is to look back at where we've been. And so if we do not destroy ourselves, we get to be something more than what we are now. And when we start talking about what this more is, people start drawing, the Terminator, right? And I don't think that's any more accurate than the nuclear bomb, especially given where I work. But neither is this. So we try to imagine what we're going to be, and it's hard to tell. All we can say for sure, I think, is to look back at our evolutionary past and say, we will likely merge with our technology, first of all, right? We have in the past. We will likely form a collective with each other. We already have done that, but it will probably deepen and become more interconnected. One yet separate, separate yet one. Does that sound like the Trinity or anything similar to any of us here? And we will form a society, right? And that no one of us would be God, but the society would be something beyond what any one of us would have. We probably won't stay where we're at now, just as life always spreads out into wider spheres. We'll probably do the same thing. And what kind of a being would this be? Well, this is a famous line from the original Battlestar Galactica, but borrowed from Lorenzo Snow. As God is now, as we are now, God once was, and as God is now, we may become. This is the sort of God that the theory of evolution predicts, a God in nature, not necessarily a God of nature. So obviously one of the questions you could ask is, how likely is this being to exist? And that's kind of where we're gonna have to end it because I'm out of time. But how likely is it that such a being that I just described exists? Is there a God? Again, we cannot answer that question. To do so would be unscientific. But there's nothing unscientific about asking how likely is something given what we already know. In other words, what are the consequences of our existing theories and beliefs? And our visible universe, our galaxy has trillions of stars. Our visible universe has billions of stars, sorry. Our galaxy has billions of stars. Our visible universe has trillions of galaxies. And the universe itself may well be infinite in size. Not only that, the universe may be one of many universes and we don't know that either, right? There's certain cosmological questions that have yet to be answered. But imagine with me a being that is a collective of collectives of collectives, hierarchically extending a vast distance, possibly with an infinite history, going back an infinite amount of time in infinite dimensions, in infinite universes, all interconnected and webbed together, with an infinite past wisdom and possibly a near infinite computational potential. Is it surprising then that any of us call such a being God or would be willing to worship such a being? The answer to whether that being exists depends on the answers to certain cosmological questions which we do not yet know the answer to. For example, is it possible to communicate between worlds in the multiverse? We don't know the answer to that question. If it is it bandwidth limited? Those questions depend on answers to quantum gravity and some other things that we do not yet know. But what we can say is that if such a being exists, we can probably predict some of his attributes. And that's what we've tried to do today by looking into our own past. Thank you.